Just very quick refresh about functions. As I already told in the last lesson, we have x and y as an input and an output, and there is a function that is transformation of input into processed output that we would like to have. So it's very basic school math concept, and I think we can just quickly remind ourselves of composition of functions. It's basically when we have more than one function and put one into another. In this case, we have sine of x and x squared, two functions, and composition means we take one and substitute it into another one. And so we can get something like this. And you can see that g of x is above g of f of x is highest in the hierarchy. It's outside. So basically it means x squared is our outside function, and the value of x we substitute with another function within the brackets. F we substitute it with f of x. In this case, sine of x. So we substitute f of x with sine of x, and we got sine of x squared. So basically, again, this is how it looks like. Properties of composed functions. I think it's not just properties of composed functions. Periodicity is property of sine function, periodic functions, and non-negativity is a property of squared functions. So in this case, when we got composite function, it got is both wave like and always positive. So when we do composition, we kind of merge these two qualities, these two properties of different functions into one. So in machine learning, it's the way how we use functions all the time, and it's very rare that we use simple functions in any task that we have. So it gets optimized, trained, and deployed, and usually composite functions are used in practice. Understanding composition is essential because neural networks, for example, are essential deep compositions of functions layered on top of each other. We need to know how to work with them and, at the very least, understand what they are. All right. And another concept, minima and maxima. So every function has minima, some doesn't have maxima point, but minima, at least they have. Basically here, minima maximum points means it's a particular peak where the particular value is the smallest one around, or it's the largest value around. And this is how it looks like. We have maxima points and minima points. And in this case, it's a composite function. You can see that it looks like, if you see just these peaks, you can see that it looks like parabola that constantly growing. And another side constantly decreasing. This how we can see one composite functions took qualities, properties of two separate functions. And in this case, we won't have, we will have only local minimas on maximus and maxima at these points, but we will never have like the biggest, only one biggest or only one smallest point. No, we have smallest points right here, but we won't have maximum point at the global scape. So that's it. We recalled functions in math, learned how to build compositions of functions, discovered what minimum and maximum of functions are, and now it's time to apply our knowledge.